Good day and welcome. I'm Mr. Simons. In this lesson, we'll be looking at rate of change, specifically past exam questions that were asked. Right? So, November 2016, question goes as follows: the number of molecules of a certain drug in a bloodstream, T hours after it has been taken, represented by the equation MT MT equal minus T cubed plus 3T squared plus 72T, and T is less than 10 but greater than 0. 1.1, they say determine the number of molecules of the drug in the bloodstream 3 hours after the drug was taken. Right, so my time, 3 hours, place in T, I place 3, becomes minus 3 cubed plus 3 squared plus 72 times 3, it gives me 216 molecules of this drug in the bloodstream. 1.2, determine the rate. So once I use the word rate, I need to find the first derivative. So determine the rate at which the number of molecules of the drug in the bloodstream is changing at exactly 2 hours after the drug was taken. Right, so because of rate, find the first derivative. 3 times negative 1 gives me negative 3, 3 minus 1, 2. 2 times 3 would give me 6. 2 minus 1 becomes 1. 1 times 72 becomes 72, and T falls away. Say 2 hours, so my time there is 2 hours, so I substitute 2 in. That's 2 in the place of T. 72 plus 12 minus 12 gives me 72 molecules per hour. So number of molecules in bloodstream 2 hours after the drug was taken, 72 molecules per hour. So very important. See the word rate. We find next question: how many hours after taking the drug will the rate? So rate again, first derivative, which the number of molecules of the drug in the bloodstream is changing, be a maximum. So they want to know when will the rate be a maximum. So rate is first derivative, maximum I'll have to find second derivative. So first derivative, 3 times negative 1, negative 3, T squared 2 times 3 gives me 6T plus 72. Because of a maximum, I have to make the second derivative equal to 0. Second derivative, 2 times negative 3 would give me negative 6T. 1 times 6, 72, a constant falls away. That is equal to 0 because they said maximum. So when they say maximum, minimum, my derivative must be equal to 0. I take 6T over, negative 6T becomes positive 6T. From there, 6 divided by 6, my time equal 1 hour. So after 1 hour, the rate at which the number of molecules in the drug bloodstream is changing will be a maximum. Let's look at this exam question. November 2013. Industrial process requires water to flow through its system as part of the cooling system. Water flows continuously through the system for a certain period of time. The relationship between the time T from when the water starts flowing and the rate R at which the water is flowing through the system is given by the equation R equal negative 0,2 T squared plus 10T, where T is measured in seconds. First question: after how long will the water be flowing at the maximum rate? So once they use the word maximum and rate, we have to find first derivative and make it equal to 0. After how many seconds does the water stop flowing? So we want to know when it will be equal to 0. Right, so 10.1, after how long will the water be flowing at the maximum rate? So given to us R equal negative 0,2 T squared plus 10T, maximum rate. So I have to find the derivative. I differentiate R with respect to T. So 2 times negative 0,2 gives me negative 0,4. 2 minus 1 leaves T to the power 1. 1 times 10 stays 10. 1 minus 1 is 0, so T to the power 0 falls away. Because they said maximum, I make it equal to 0. So 0 equal negative 0,4T plus 10. If I take negative 0,4t across, it becomes 0,4t equal 10. From there, always divide by the value in front of t, or coefficient. So 10 divided by 0,4, t equal 25 seconds. Right, so that's after 25 seconds, my water would be flowing at a maximum rate. Right, second question, after how many seconds does the water stop flowing? So we have R equal negative 0,2t squared plus 10t. When the water stops flowing, my rate must be 0. No? So 0 equal negative 0,2t squared plus 10t. Take out t as a common factor, and I'm left with negative 0,2t plus 10. T then equals 0, or negative 0,2t equal negative 10. T equal negative 10 divided by the coefficient, negative 0,2. So t equal 50 seconds. So the water is not flowing at 0 seconds, and it stops flowing at 50 seconds after it has started. So I hope you follow and understand. Right, let's look at the next exam question. Right, next question comes from September 2016, Eastern Cape, my home province. Right, a water tank has both an inlet and an outlet which regulate the depth water it contains. The depth d in meters is given by the function dt equal 3 plus half t squared minus a quarter t cubed, where t is measured in meters, t is measured in hours, and very important, we start from 8 o'clock. Calculate the depth of the water at 8. Calculate the rate at which the depth is changing at 11. What happens to the depth of the water at 11 o'clock? What time will the inflow of water be the same as the outflow? Right, so without further ado, let's solve. So calculate how deep the water is at 8. At 8, that's when we're starting, so my time equals 0. So I have the equation dt equal 3 plus half t squared minus quarter t cubed. My time there is simply 0. So 3 plus half 0 squared minus a quarter 0 cubed leaves me with 3 meters. So at 8 o'clock on the dot, I have 3 meters of water. 11.2, they say calculate the rate. So once we see this word rate, we need to know we have to find the first derivative, which the depth of water is changing at 11 o'clock. Right, so remember we started at 8. So the time here, 11 minus 8 equal 3 hours. So we want the rate at which the water is changing, or the depth is changing, after 3 hours. So for rate, I'm going to find first derivative. So dt equal 3 plus half t squared minus a quarter t cubed. First derivative, 3 falls away. First derivative of constant, always equal to 0. 2 times half, or half of 2 is 1. 2 minus 1 gives me 1. 3 times 1 becomes 3 over 4, so negative 3 over 4. 3 minus 1 gives me 2. I said after 3 hours, so first derivative, I substitute 3 in the place of t. T becomes 3 squared. 9 times 3 would give me 27. So I have negative 27 over 4, and 3 times 1 is 3. 3 minus 27 over 4 gives me negative 15 over 4 meters per hour. So that's the rate at which the depth is changing at 11 o'clock. Alright, so you follow rate, first derivative. Time substituted into the first derivative. Let's look at the question. What happens to the depth of the water at 11? Because it's negative 15 over 4, the water is decreasing. Right, if it's positive, yes, I would say it's increasing. But because it's negative, there the water is decreasing. Right, now they want to know for 11.4, at what time will the inflow of water, the water going into the system, be the same as the water flowing out of the system? So again, we have dt equal 3 plus half t squared minus a quarter t cubed. Find the first derivative, meaning we want the rate at which the water flows. So the rate, in short, is inflow and outflow at the same time. That's the rate of water flow. So t, first derivative, t dash on a t dash. T prime t equal 1t minus 3 over 4t squared. So 2 times half give me 1. 3 times negative 1 over 4 gives me negative 3 over 4 t squared. That there equal 0. So from there, multiply the denominator away. 4 times 1 gives me 4t, and there I'm left with negative 3t squared. Take out t as a common factor. 4t divided by t gives me 4. Minus 3t squared divided by t gives me minus 3t equals 0. So t equals 0 or t equal 4 over 3. Right, so time equal 4 over 3 times 60 minutes. 60 times 4, 240 divided by 3 gives me 80 minutes, which is an hour and 20 minutes. So at 8 o'clock, my water going in and out is the same because no water flow. And then if I add an hour and 20 minutes to 8, at 20 past 9, the water flowing in and out is the same. So remember, rate of water flow is my inflow of water equal to my outflow of water. Right? Next question. They say a mass of a baby in the first 30 days of life is given by mt equal t cubed minus 9t squared plus 3000. T must be less or equal to 30 days or greater equal to 0. T is time in days. M is the mass of the baby in grams. Write down the mass of the baby at birth. 10.2, a baby's mass usually decreases in the first few days after birth. On which day will the baby's mass return to its birth mass? 10.3, on which day will this baby have a minimum mass? 10.4, on which day will the baby's mass be decreasing the fastest? So as I say, you can pause and attempt to answer it, right? Or you can just work through with me, but yeah. Always try to do the problems yourself so you can see what errors you make, so you can practice the errors out of you. So 10.1, write down the mass of the baby at birth. So at birth, my days is 0. No? So there, in my equation, time is 0, 0 cubed, plus 90 squared plus 3000. So baby at birth weighs 3000 grams or 3 kgs. Now they say baby's mass usually decreases in the first few days after birth. On which day will the baby's mass return to its birth mass? So its birth mass equals 3000 grams. So the equation t cubed minus 9t squared plus 3000 equal 3000 because it has to return to that. 3000 minus 3000 gives me 0. So I'm left with t cubed minus 9t squared. Take out t squared as a common factor. T cubed divided by t squared gives me t. 9t squared divided by t squared gives me negative 9. Right, so t equals 0 or t equal 9. Right, so at birth the baby weighed 3000 kgs, and on the 9th day the baby also weighed 3000. Oh, not 3000 kgs. Yo, that's too heavy. 3000 grams or 3 kgs. Right, point 3. On which day will this baby have a minimum mass? So once you see the word maximum or minimum, I have to find first derivative and make it equal to 0. So mt equal t cubed minus 9t squared plus 3000. My first derivative, 3 times 1 gives me 3, 3 minus 1, 2. 2 times negative 9 gives me negative 18, 2 minus 1 gives me 1. The first derivative of constant is 0, so that falls away. Because they said minimum, first derivative equal to 0. So 3t squared minus 18t. Take out 3t as a common factor, so 3t squared divided by 3t. 3 divided by 3, 1. T squared divided by t gives me t. 18 divided by 3 would give me 6. T and t cancels. So therefore t equals 0 or t equal 6. So on the 6th day the baby will have a minimum mass. Right? On which day will the baby's mass be decreasing the fastest? Right, so from the previous problem top, baby reached minimum mass by the 6th day. No? So basically from 0 to 6 days the baby's mass was decreasing. Right? So we have the equation. Because it's decreasing, I find the first derivative. 3 times 1 gives me 3. 3 minus 1, 2. 2 times negative 9, negative 18. 2 minus 1, 1. Right? The fastest is the same as asking maximum. So maximum of decreasing, I find the second derivative. 2 times 3 gives me 60. 1 times negative 18 gives me negative 18. That equals 0. 60 minus 18, if I take 18 over, comes plus 18. 18 divided by 6 gives me 3. So therefore on the third day, the baby's mass was decreasing the fastest. Hope you enjoyed the lesson, very important. Rates of change, so instead of asking optimization, we can ask rate of change. Please like, share and subscribe. Wish you nothing but the best. God bless.